So to do this, we need to convert from polar to coordinate system. If you remember how we started our session today, we said that we put a point on the Cartesian space, and in math we just draw a line, but in Python we have to create a sequence of points leading up to that point. So for example, 5 steps along the x-axis, and then 5 steps along the y-axis, and that's where we put the point, and then we draw a line leading to that point. But if you notice here, when we do draw this vector, we have now formed an angle. We have formed an angle from the x-axis to the line. There's a word for this. I think there's initial side and the terminal side. So there's the initial side relative to the x-axis. This is the initial side. That's the terminal side relative to the y-axis. That would be the initial side, and this would be the terminal side. At any rate, so on the Cartesian coordinate system, we have the values x and y, and that produces a point. In the polar coordinate system, we have r, which is the radius, and the polar coordinate system is a circle. We'll see this in a second, and the angle theta. So if you know these values, if you know the length of the vector and its angle from the initial side, then you will know its position on the polar coordinate system. But there's a way we can convert. We can go from one system to another system. Let me show you the polar coordinate system on its own. Polar coordinate system. Okay. These are the coordinates on the polar coordinate system. Obviously, one point would be the length of the vector. That will always be the case. And then there is radian, and what's the other one? Yeah, in radians, how far it is from the initial side. Okay. And this is the radian system. You get the idea, I hope. Okay. So if you want to, for example, go from polar to Cartesian, you calculate it this way. We go x will be equal to r, which is the radius, times, sine of the angle theta. And if you want the y, you multiply it by cosine theta. This is how you convert. We now have the angle theta for our cosine similarity. Now we just need to multiply it by, we need to calculate the sine of that angle, which will give us the ratio. For sine, it will be the ratio will be opposite over hypotenuse, right? And cosine would be adjacent over hypotenuse. So if I want the x and y from my cosine similarity, I'm going to come back to my notebook. I will call this COS or CSIM1, cosine similarity for the first comparison. Let's make it 1 and 2, right? The cosine similarity of vectors 1 and 2. The cosine similarity of vectors 2 and 3. Or let's make this 1 and 3. To convert to Cartesian. Now, we cannot plot these word vectors because we have to project this in a 2-dimensional space. These are 4-dimensional. So what we're going to do is we're going to create 2 vectors that go from 0 to 5. Basically, let me show you what I mean. Okay, so I'm going to create those 3 vectors again. Let this be 5, 5. Okay, 5 steps from the x-axis, 5 steps from the y-axis. Let me go back to what I had before. I need to be more careful. Okay, so that's the, let me make the vector a bit longer. So it will go from 10 to 10. Now, after we have calculated the cosine similarity, we need to grab the x and y for the second vector. So the formula was as follows. If I want to draw the second vector, I'm going to go V, W2. Okay. The position of this vector is relative to vector 1. So for its x, or it's x. I'm going to call the vector function to draw a vector. And this will have to be a tuple. So we have x and y, correct? So it's going to be math. Was it sine or cosine? I think it was sine. Math dot sine of c cosine similarity of 1 and 2. Same thing for y. Just going to copy this bit. But this would be cosine. Okay, now I'm going to draw the second vector. We'll make this red. Okay. Oh, well, is this good or bad, or is this close or not? Not close. There's only one way to know it. That's to create a third vector. So I'm going to create a third vector. This will be the cos. Now the angle for these functions would be the cosine similarity of 1 and 3. So we first compare 1 and 2. Now we compare 1 and 3. And let me make the first vector black. That's that's our point of reference. And then we will make the green one. Let me draw this again, just so you can see the black vector. So that's the original one. And then let's add the third vector. Third vector. No, one more time, because I forgot to reassign this value. So again, this is the first vector. This was a dog, right? Supposedly dog. This was cat. And now let's do the building. And let's make the color green. Yeah. So you can see dog and cat are closer to each other. They have a smaller angle.